Hello everyone, welcome to Principles of Operating Systems. I am Gomati, working as Associate Professor in Department of Information Technology. In this lecture, we are going to discuss about process and its various states. The contents that are going to be covered under this lecture are what is the process, the actual structure of the process, and then what are the different states that the process come across. We hear the term process frequently. First, we'll see what is the process. Process is defined as program in execution stage. It means that when we run the program, the corresponding process will be created by operating system and assign unique ID to that process. So, when process is initiated by the user, the operating system loads process into main memory, that is RAM. When process is in main memory, it has different subsections such as text, data, heap and stack sections. Here, text section in process contains set of codings that are written under corresponding program. Next section is data that contains global variables that are declared in that program. The stack section contains information related to functions such as parameters which are passed to the function, return address where control return back to calling function from called function once the function execution is over, and then local variables which are declared inside the function. So, the stack section overall contains function parameters, return address to calling function and local variables declared in that function. The last section is heap memory, that is allocated to variables which are declared under particular process at runtime. Usually, there is a confusion exists between process and program. Now we will discuss about the major difference between process and program. First we will see what is program. Program contains set of instruction, but the process is an instance of an executing program. It means that when we execute a program, the corresponding process will be created by operating system. Next one, program is called as passive entity since it is a set of coding and does not do anything. But the process is an active entity since when process is executed, it will do some specified task. In third point, it is conveyed that when we store a program in memory, it exists until it is deleted. But the process exists in memory for short period of time until it gets terminated after completion of task. Fourth one is that the program requires memory to store the instruction, but the process requires set of resources to complete the assigned task such as CPU, memory, I/O devices for its entire life cycle. When a process is created, it goes through the different states to complete the task. This diagram shows various states of the process such as new, ready, running, waiting and terminated states. Here, new is the first state. The process enters to the state when it is created. Then, the process moves from new state to ready state when it is loaded in main memory. Later, it will be dispatched to CPU for its execution. At that time, process moves from ready state to running state and then start to run under CPU. While green process is running, another new red process arrives to the system. That red process moved from new state to ready state. At the moment the red process came to ready queue, the green process moved from running state to ready state since the red process is having high priority than green process. Here, green process is interrupted and moved from running state to ready state. Now the CPU is free, hence the red process is dispatched to CPU. Here, the red process starts to run under CPU. Now, another yellow process arrives to the system and it is added to the ready queue. Now, the red process stops its execution because it requires I/O operation. For example, it needs to perform print operation. Since the process requires printer instead of CPU, it comes out from running state. but the printer is used by some other process, hence the red process starts to wait in printer queue. At the time CPU is free, so the green process dispatched CPU for execution. Now green process start its execution. Once the printer is free, red process completed the print operation and moves to ready state and waiting for CPU. At the same time, green process completed the task and moved to terminated state. Next, the yellow process is dispatched for execution. Now, the yellow process starts to run under CPU. Once the execution is over, yellow process moves to terminated state. At last, the red process will do the task in same way. From this concept, we come to the conclusion that when we execute a process, it comes across the different states. When it is created, it is in new state, then moves to ready state when it is loaded in RAM. When process is dispatched, it is moved to running state. From the running state, it moves to three possible states such as terminated, ready and waiting state. When process completed the task, it moves to terminated state. If it requires any IO operation, at the time it moves to waiting state. If the current process is interrupted, it moves to ready state. Hope you all understood about process states. Thank you for listening.